So here's number 6. Solve minus 2x plus 7 is less than 25. Well, again, we're going to treat both sides equally. And the first thing we do is subtract 7 from both sides. And we get 18 is less than minus 2x. Or minus 2x is greater than 18. And now when we divide both sides by minus 2, this is going to change the inequality, like we talked about before. So we have x is less than 9, and we really should plot this on the number line. 1, 2, 3, 3, 4, 5, 6, 7, 8, 9, somewhere out here. And it's less than 9, so it's an open circle. And we shade everything to the left. Okay, solve absolute value of x plus 11 equals 11. So this one, nobody in the history of learning math has loved absolute value, because there's two cases here. If the absolute value of something, in this case absolute value of x plus 11, if that is equal to 11, there's two cases. X plus 11 could be equal to 11. That's sort of intuitive, right? But there's another case. What if x plus 11 was equal to minus 11? Right? If x plus 11, if this stuff in here was equal to 11, then yeah, for sure the absolute value would be 11. But if the stuff in there, right, so that's what this stuff is, if that stuff is equal to minus 11, the absolute value would still be 11. Okay, so now we just use our algebra and we can see that x here, you could do mental math almost. The only thing x can be in this case is x equals 0. And again, you can use mental math, or let's subtract 11 from both sides, and you can see that x equals minus 22. So these are our two answers. Okay, and now this one, solve absolute value of x plus 4 minus 7 is equal to minus 2. So we're going to isolate our x plus 4, our absolute value of x plus 4 by adding 7 to both sides. And we get abs x plus 4 is equal to 5. Now just like this case up here, this junk inside the absolute value sign can be positive 5. That's x plus 4 equals positive 5. Or that stuff inside the absolute value, that junk, x plus 4 can equal minus 5. Right? There's two cases. So this one, again, mental math. X equals 1. There's only one number. That's the number 1 plus that we add to 4 to get 5. And here, x equals minus 9. Identify the coordinates of the vertex of the function shown below. Oh, I don't see a function. I'll skip that one. But well, let's just say the vertex is going to be the highest point or lowest point. So if you have a function, let's say like this, you would just read that to be the vertex. Or if the function instead looked like this point right here would be the vertex. The vertex is the highest or the lowest point depending on the shape of the function. And a line would have no vertex. This would be, you couldn't have a highest or lowest point because theoretically the line would go on forever and ever. Okay, number 10, restaurant menu features 5 appetizers, 7 entrees, and 3 desserts. A customer orders 1 appetizer, 1 entree, and 1 dessert. How many different meals can he order? Well, there are 5 choices for the appetizer that he could make, times 7 choices he would get for entrees, times 3 desserts. And this is 105. Suppose you are choosing a 6-digit personal access code. The code is made up of 4 digits, chosen from 0 to 9. Oh, really important. How many numbers are from 0 to 9, including 0 and 9? It turns out there are 10 numbers. You can list them out, or 2, 3, 4. A lot of people will just jump and say there are 9 numbers from 0 to 9, but they'll forget the starting number or the last number. So there are 10 numbers here, followed by 2 letters chosen from A to Z. Well, no one ever messes that up. From A to Z in our alphabet, the English alphabet, there's 26 letters, so that should be easy. So there's 10 digits, and A to Z, there's 26 of those guys. 26, 10 of these. Any of these digits or letters can be repeated. Use the counting principle. The counting principle is what we used in 10 to find the total number of personal access codes that can be formed. So it's 6, 1, 2, 3, 4, 5, 6 digits. The first 4, these first 4, make this a 10 right here. There's 10 for this spot, 10 for this spot, 10 for this spot, and 10 for this spot. And then followed by 2 letters, so there are 26 letters, 26, 26, and we just multiply that out. Man, I should be able to do 26 squared in my head. There we go. 26. Times 26, 676. So this part is, oh, watch this. So this is 676 with 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. And let's put some commas. So there's 6,760,000 possible choices. Okay, just enough time to do this. The population of a city of 73,400 residents declines 7.2% each year. Write and solve an equation to find the population after 5 years. Okay, so if something goes down by 7.2%, 92.8% is left after each year. I might give you a second to think about that, right? Let's do a really easy example. If something goes down 10% each year, then it should be, then it will be 90% of its original value. So here we have 73,400 times 0.928, and we're going to do that for 5 years. And that's going to give us our answer. I have just a few seconds to do this. 0.928 times 0.928 running out of time times 0.928 times 0.928 equals times 73,400. I believe the answer should be 50,516. Also, we want to round or something, but we can't have a 8/10 of a person. That would just be sick. So there it is. All right. Pick up in just a second with number 13.